going to go over homework 10, which is going over template, overriding operators, linked list, and binary search trees. So basically, here for problem 1, it's asking us to use template programming to implement a stack so it can hold any data types. So here I show you for int stack, and here's the string stack. Briefly, we're instantiating something called int stack using the class stack with a type of int, and we're adding 10 and 20 to the stack. I'm going to show it to you. It's going to remove the last element from the stack, and it's going to show it to you, and then we're just printing a new line. And this is also shown for the string stack, just to show you the template programming. Now before I show you the results, let's go over the code. Stack for the headers file looks like this, where the class stack is using template programming, which can take any data type. For this class, it has three private variables, where a list represents a dynamic array that stores all the elements in it regardless of its type. Max size represents the stack size, and the number of nums items represent the number of elements in the list. Now here are a couple of methods that we have in this class stack. One is this stack. This is a no args constructor. This is the deconstructor for the stack. This push method is you're going to take in an element. Doesn't matter if it's type, that's why it says T for type. Regardless of its type, it's going to add that element to the stack. This is going to remove the last element from the stack. These two are not returning anything. This top method it's supposed to get the top element of the stack and then returns that data type. Now the output method just displays the stack but returns nothing. To show the implementation here, we're going to take a look at stack.cpp. Now for the no args constructor, we're initializing the max size to be 100 and nums items to be 0. Now what this line of code here does, it's setting the list to initialize the max size, which is the size of the dynamic array. And this is the deconstructor for the stack. We are just deleting the list just to free up some space. Now some interesting methods here. This is the push method. Now the aim of this push method is to again add an element on the stack, specifically at the end. So before we do so, we're going to go ahead and check to see if the stack is overflowing, and by doing that we're going to use an if statement to see if the nums of items is greater or equal to the size of stack. Now if it is, it's going to throw this stack overflow error messages. Now if it's not, it's going to go ahead and get the list, take the nums of items, increment, and then set the value to that to be the last item of the stack, which again is the point of this method, is to add the end of the stack. Now for this method here, pop, we are specifically removing the last element from the stack. To do so, we have to first check that the stack is quote-unquote underflowing. Now this only the stack is underflowing if the number of items is equal to 0. If it's not, then we're just going to go ahead and decrease the number of items, which ultimately removes the last item from the stack. Now the top method. Now again, we are going to extract the top element of the stack and return depending on the data type. Now again, we also have to have to check to see if the stack is empty. If numbers of items is equal to 0, that means the stack is in fact empty, and we can't return nothing on the top of the stack because it's empty. Now in the case if it isn't and it's not empty, go ahead and access the list by getting the nums -1. That will get you the top of the stack and thus showing it. Now we are not removing from that stack. It's going to return that. Now the output is just simply just go ahead and just like displays the top of the stack. I'm just removing the std because we don't really need that. I get in the habit, but I already used the namespace. So for this, we're gonna basically print the bottom of the stack to show whatever is on, just to show the top to bottom of the stack. Now, to do this, we're just using a for loop, and it's gonna for loop through each nums of stack, and then it's gonna display it, and then displays this print statement. Now, I'm gonna show you problem 1. We added, remember, this is the bottom of the stack. We added 10, then we added 20. So 20 is on top of the stack, right? Then we're gonna pop with top element. 20 was the top of the element of the stack. So then, and the next, when we display it, we should only get 10 and removes 20, which is in fact what it does. Then we're going to show you strings of stack, where we're going to push Maze, then Jack, and then we're going to show you the output. The bottom of it, the stack, should be Maze, and then the top of it should be Jack. Then we see Maze and Jack, and then when we do a pop, it's going to remove the top element, which Jack should be removed, and we should only see Maze, which is in fact what we do see here. Okay. Problem 2 is basically us overloading a couple of operators, and we're going to do some calculations for complex numbers. So briefly, this is what we have going on here. We have a complex header file. For this complex header file, we have two variables, real and imaginary. They both are the type of double, and real represents real numbers, imaginary represents imaginary numbers. These are, let me lower this, these are the methods that we are interested in. So complex is a no args constructor for the class. This is going to be a parameterized constructor that takes in a real and imaginary, and this is the deconstructor for the complex class. These are our overloading operators that were overloading the plus, the negative, the multiplication, and the division. And we are returning its complex type. Now, again, the operator plus adds two numbers together. Operator minus subtracts two numbers. The operator multiplication multiplies two numbers. The operator with division divides those two numbers. Now this part is interesting. This overrides this operator right here, and the aim of this is just simply show the results. We use the friend method basically to help access the private members. So now that we look in the implementation, we are looking at the no args constructor. The no args constructor sets the real to its real variable to 0.0, imaginary sets to 0.0. And then here we are using the parameterized constructor, passing in a real and imaginary number, and then setting that real number that was passed in to the real variable to the class, and same thing for the imaginary. And then this is the deconstructor for the complex class. So all of these from the plus, subtraction, and the multiplication operators are operating the same form of logic, where we're passing a number, and then we're going to perform the calculations on the respective arithmetic computation. So to do so, first we're going to get the real number, and we're going to add it to the num real number that it gave us. And then we're also going to take the imaginary, and we're going to add it to the num dot imaginary, and then we're passing into this constructor right here. Okay, and then we're going to return it, and then when we do it here, we're actually invoking and overriding the plus operator and actually adding this number and this number. That's how that works, and that's pretty much similar to the subtraction, multiplication, and division. Now, the division operator is a bit unique in a sense that we could potentially run into a case where the denominator is 0. Now, if the denominator is 0, we have to make sure to throw the dividing by 0 error. Otherwise, we're going to crash the program. It's going to halt. In the case that we're good, we do the same thing how we did the plus, minus, and multiplication operator, where we take the multiplication times by the num.real. This is multiplying the first number, right? And then this is we're adding the imaginary times the num.imaginary, and then dividing by the denominator. Okay, and then we're doing the same thing for the second number, and then there you go. That is the operator division. Here we are overloading the this operator here just to show the results. Here returning the OS, which just helps to support the output chaining. Okay, so if we go ahead and show you problem 2, we pass in. So the first number, the real number is 6, the imaginary number is 4. The second one, we're doing imaginary 1, a real 1, imaginary 2, and then we're just performing those operations, and then this is what it would output. Again, remember what I mentioned, that the division operator is unique in the sense that it needs to have a try-catch surrounding around it, because it could potentially be dividing by 0, which will error out and cause the program to halt. Okay. So for problem 3, we are going to be doing working with linked list and overloading the operators. So I can't explain this, but I think it's best if I go ahead and go into code. What are we doing here? So first, I created a class called Node and we're allowing template programming, which allows the Node class to accept any type of data. And in this class, we have two public members called value, which could can have any data type, and then the next. So this just helps to get this is the dynamic array for that gets the next node. Now here we just have a few methods. This is the no args, or the default constructor, call it what you will, and the aim of that is to set the value to really any type of data, and the next variable points to the to null. Now this is the parameterized constructor, which updates the value to the value that's being passed in, and then sets next to still null. And then the deconstructor, we're not doing anything to it, because you'll see soon that the linked list, we are clearing out the list by deleting the next element. So here for linked list, we're using template programming. Here we're having two private members called length and head. The length just represents the length of the list, while the head refers to the first node of the list. So this is the head is set to null, and the length of the list is set to 0. This is the no args constructor. Now going to the deconstructor, we have a few things here. For the linked list to deconstruct it, we have to loop through it and then set to each node to delete the node to free from space. So what this reads is like, hey, if the head is um, not null, then go in and hey, we're gonna create something called P, set it to the address of the head, get the head, set it to the next um, node, and then we're going to check to see if the P is not null. And if it's not null, then go ahead and just delete it. And this helps clear out and removing and freeing some space. So for the insert at the end method, we're passing in a value. And the aim of this method is to simply just to add the element at the end of the array. And to do that, we're just going to go into it. So we have something called new element. The aim of this is to create a new node, and the new null is just going to be set to nothing, to null. And we have to check to see, hey, is there a head? If the head is not there, then we need to update the head to be equal to this guy, to the new element, to new node essentially. Now, in the case it's not, then we're just gonna go ahead and loop. We're gonna go through here. We're gonna set a P, initialize it, initialize it to the null, to the head, and then we're gonna loop through. Essentially here we're going to loop through the nodes when there is a node pointing to another node, and then we're going to get that P and then update it to the next node until the P gets until we assign it to a new address. And if we keep looping through, and in a case where P is not pointing to a next address, it's going to break out of this loop, and then we're going to set the P to the new node. And then, of course, we're adding something to the list, so then we have to increase the length of the list. So the deleted by key is a method that returns a Boolean type. We have to pass in a key, and the idea of this method is just to delete a node and making sure that once we delete a node, the linked list is still connected and continuous. So, and this method is quite long, so bear with me. Here we're checking to see if the head is null. Now, if the head is null, then return false. We don't need to be deleting any key. But in that case, if the head off the bat matches if the key is in the head, then just go ahead and update to the next node. Now, to do that, we have to first create a P and then copy the head's memory address, then get the next head, and then assigning it to the head. Okay, and then afterwards, just delete the previous head and then decrease the length and then return 0. This just tells us that, hey, the key is in the head, and just update that head to the next node. Now, here is what I'm going to be explaining. So we're going to have something called current head, and we're going to initialize to the head's address. So we're going to loop through here, loop through the list when the current head is pointing to another node. So okay, this is like in the middle. Okay, now in the case if we did find that the current head has the value that we want to delete it, break out, okay, and then continue the rest of the code. But if it isn't, then keep updating the current head to the next node's address. Here we are checking to see if the current head's next is null, and if it is null, then that means just return false. Here is in the case when we do find the element and we're actually trying to delete it. So we're going to have something called P, and we're going to initialize the node to the next that we want to be deleted. And then we're updating the next node to the next of the current head, and then deleting that P, which is the node that we want to delete, and overall decrease the length of the list and then return true. Okay, just a few more and then we're done. So the aim of this display list is just to display the list. We're grabbing a current head and then we are setting to the head's address. And then, hey, if we still have, we're going to loop through this part. If we have a current head and it's not null, go ahead and print each value. And each value, it's going to have this little arrow in between just to make it easier for us to read in the console. And then update the current head to the next node address, and then print this at the end of the list just to show that we're pointing to null. This is where at the end of the list, and that's it. So this right here, operator plus, you'll find that in the instructors it basically they want us to overload a method, and I choose the plus operator, and this basically we want to add two lists together regardless if it's type. It could be adding two strings, two ints of a list together, and this is it reads as follows. We grab the new list. We're creating so we're just creating something called new list. We're going to also be creating P. So new list is a linked list, but P is a node. We're setting the P to the head's memory address. And so we're going to loop through each node. Now, if that node is not null, get into this loop, and we're going to access this new list. We're going to add the element of P's value, aka that node, at the end of the list, and then update the P, which is the node, to the next node's memory address. Now, that's great, but then we got a second list going on, and so now P is being reassigned to the second head. Same thing, really. This is the same thing, except this is the first list, and this is the second list, and we're doing the same thing, except we're just adding it to the new list, and then we're returning that new list of whatever type it is. Okay, so now here, basically the aim of this is just to override this operator here, just to print the list. And again, we're using the friend modifier to allow the operator to access the linked list private variables. Okay, so this is just the declaration of it, and this is the implementation of it. And basically similar to the display list method, except we're returning the OS, which is an OS stream to support the output chaining. So let's revisit the main and take a look of what it looks like. All right. So basically here we have list 1. List 1 is a type int. This is list 2, type int. And then this is us combining list 1 and 2. So let's just take a look here. No, bring this little guy up. Okay. Hey, we got a list. We created a list with linked list with a type int. We're going to add 1, 20, and 3 at the end. So we're adding 1, then 20, then 3 at the end, right? So that's, and then we're displaying it. Then we're displaying it. And then we're going to delete 1. So when we delete it, after deleting, you'll see that 1 is gone. And that's us displaying it. Now we're doing the same thing, just to prove that it works for list 2. It works the same thing. The only thing that we added for list 2 is 5. Okay? And now we're going to take int list, which is us creating something, and we're adding list 1 and list 2 together. This is us concatenating the two lists together. And then we are going to show it to you. And this part right here, we're overloading this operator. And that's why we can see it right here. Now here, we are doing the same thing, except we're just doing it to a string. Okay, you're going to see we have eggs, bread, butter, eggs, bread, butter, and then null, displaying list, we display the list, groceries, this is us overloading this operator here. And then we're going to delete right in the middle bread. And we should just see eggs, butter, null, eggs, butter, null, displaying the list after we delete it. And there you go. And that is it. Information. So a couple of benefits from templates. It's great to add into your code in case if you don't want to have 10 different functions that's really doing the same thing. It's just it's using different data types, and this just promotes code reusability and flexibility, and it really keeps the code simple. So essentially it boils down to it's performing the same functionality regardless of its template data. So that's why we really should be using template programming instead of having 6 different methods that's doing the same operation, just has different data types. We just reduce it down to one code where it doesn't matter the data type, it's just but it's performing the same operation. That's basically the benefits of template programming. The other talk point I need to discuss, so I've included some comments about how operator overloading enhances code and readability and usability. So the idea of overloading operators is that you're adding customized code. So in case if this plus operator, its default behavior isn't exactly doing what I want it to do, but I do want to use a specific arithmetic operation, then I can override it, which this is, you can go here. I'm overriding it here, and this is where I can attach customized behavior to the operator, the plus operator, and it could be added to really any arithmetic computation, or any, not even arithmetic computation, but really to any symbol that you want to override or overload. And the last talking point, let's see. So for problem 3, it says explain the decision making process behind any additional operators you choose to overload. So problem 3, if we remember, it's the linked list. So I chose to override the plus operator because I wanted to demonstrate that you can in fact add 2 lists together. Now its default behavior, it's not able to do this. You can add 2 linked lists just like that. With my customization of this plus operator, it essentially just adds list 1 and list 2 together by first, adding all the list 1 into a new list, and then adding list 2 at the end of the new list, therefore concatenating list 1 and 2 together. And this is despite its data type, doesn't really matter. My point is that I'm overloading the plus operator, and the idea about this is simply just in promoting reuse. One, really, it's helping out with the customized aspect, where I am adding a behavior that I want. In this case, I'm concatenating 2 or more linked lists, and I can add more. I can keep adding another list to this, and it won't break. So yeah, that is the decision-making process behind any additional operators. The idea is to add customized behavior to any of the operators that you want to overload.